All right, here we go. So how many people are done? Guys done? All right, so here we go. I'm going to go ahead and just show you what we did first hour. Just kind of speed our notes up pretty quick here. All right, then I'll make sure I jump back. All right, this is why I feel like the first one really changing to a logarithm doesn't help necessarily because you still have to sit there and think, all right, 3 to what power equals 81? We already discussed before, going in there that answer is 4. All right, so x equals 4. All right, moving along to this one. This is why this is good. So changing an exponent, that's great. Yeah. That's great. I love getting that right in the middle of the notes. All right, love it. All right, let's see if we're okay here. But changing a logarithm to an exponent, what's 17 to the 0 power, everyone? 3, 2, 1, go. The answer is 1. Okay, so that's why this works. That makes me understand that x equals 1, and then I could write that. This one's probably good too. What is 36 to the 1/2 power? Do not say 18. What's the answer? 6. That means square root. And it's not plus minus 6. You're not square rooting both sides. You're just being asked, what is the square root of 36? It's just 6. All right. Then, in addition to the fact, it couldn't even be -6 because you're not allowed to have log of a negative number, no matter what the base is. And this actually leads into what we have to worry about when we're solving logarithms. You got to make sure your answer works when you plug it in. There are 2 things you cannot have for a logarithm. Stick this somewhere, wherever you want in your notes. This does not work, and this does not work. All right, by the way, what's the base on both of these logarithms? 10. So I'm going to put -10 here to try to really screw you up, because the person that doesn't know what they're doing would say the answer is -1. But what's 10 to the negative first? What's 10 to the negative first? 1 over 10. Oh, I don't know if I got my video here, but I was doing this with my finger. The old flip rule on exponents. But anyway, so neither one of these work. All right. You could type them on your calculator. So that's what you have to worry about when you're solving a logarithm. Make sure your answer does not create a 0 or a negative in that argument position. This is called the argument, like right here. That's just a math term. Anyway, the next one, we could say this is no calculator, because then you just leave it log base 4 of 27. That's what x equals, because I got x by itself. But make a note to self that this could also be the case. This is called the change of base formula. We did do this before break. And I should have had that in my quizzes. I really should have had that in there. The change of base formula. What is, hey, what's log base 4 of 27? How else can I write that? Choose all that apply. And then again, this used to have to be the case because like 10, 15 years ago, no calculator had that cheating button where you could write log base 4 of 27. And I showed you that before break that button does exist. And actually it exists here. Alpha, I believe it's window. Wrong. Let me see if it's alpha. Wait, is it? No, there it is. It's number 5. So when I hit number 5, I actually get to literally type this. But then I guess I'll just prove that this works. By the way, what's 4 squared? What's 4 squared? What's 4 squared? 16. Oh, this makes me sad. What's 4 to the third? Everyone should know this answer. 4 to the third. 64. What am I telling you? Your answer should be between 2 and 3. Because 4 squared, 16. 4 to the third is 64. 27 is between 16 and 64. All right. But then also understanding this log 27. By the way, if you don't close parentheses, you enjoy wrong answers. Did you hear that? And then divided by log 4, same answer. And then I could do the same thing with ln. So because I'm making a video on this one, I'm kind of showing that change of base or proving it. As long as the bases are the same, top and bottom, this does evaluate that logarithm without that cheating button. Okay, so you do have to know this. I'm seeing like when we look at AP questions, they're putting answers like this in the multiple choice, making you understand the change of base formula. So again, some stuff there. Okay, no calculator, you just say e squared. By the way, ln's log base what? 3, 2, 1, go. E. That's why it's e to the second equals x. E to the second is a number. And then I'll show you one more time where it is on your calculator You honestly should not touch your calculator once when you're doing your homework tonight, though. Sorry, it's second ln. So see that red there. And then just E is 2.718. So 2.718 squared is, well, 7.38, less than 9. 3 squared is 9. So 2.718 squared should be less than 9. Just kind of like making you think. I don't think this is smart to, change to a logarithm because it really, okay, well, you'd still have to know 4 to what power equals 1 over 16. So you could actually handle that this way, this is our next part of our notes. Another way to handle this is just to change this to 4 to what power? And the answer would be 4 to the negative second equals 1 over 16. And then 4 to this power equals 4 to that, x equals negative 2. I don't know. All right, moving along fast. This is why this one's easy. Log is log base 10. Change it to an exponent. And then the last one actually works out without a calculator. Why is ln of 1 0? Because e to what power equals 1? 0. That's why ln 1 is 0. And then you divide by 2 and you still get 0. Okay, so just a couple things to look at there. And remember, we did do this before break. Actually, we had one extra day. I thought, you know what? Solving really, it requires that you have to know everything building up to our last test. So we still did a solving day. All right, whoever made these notes, whether it be Westberg, Cooper, Gray, not sure who, here's what they want to remind you, which is what our kind of like what our quiz was doing there. Product property, power property, and then negative exponents are flips, but then also our logarithm properties. Got to remember that. And then last but not least, if we don't know this, we're doomed. An exponential scenario turns into what I really should do is highlight the positions. A is the answer. C is the exponent, the whole point of a logarithm to isolate. And then B is the base, which is the base of the logarithm, which is that subscript position. So remember the blah, 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 all right? If you don't know how to change a logarithm to an exponent or an exponent to a log, you're doomed, right? And that's why we did the quizzes. All right, now I got to get into our notes, so we're not just showing what we did the other hour. And I certainly didn't want to do all of these. I think it's over-exampled. But I do want to teach. And I want to, okay, now you guys do this and I'll walk around. I do want some evidence of teaching so that someone can look at this later. So this first one, I actually screwed up in first hour. I know I did this wrong. There are no parentheses. What I think I did the first hour is I made these parentheses, but they're not there. So that was illegal. So what should I do with that -4? I should add it. So I actually screwed up first hour. But what I did is I did this and then I changed the question. That was an illegal maneuver. Wow, I can't believe I just thought about that. So anyway, log base 3 of x equals 9. And then you expect me to do this without a calculator? Yes, because you would just circle that answer. I don't expect you to do 3 to the 9th without a calculator and get that long, big number. All right, that's calculator ready form. All right, but that's what it is. Base, exponent, answer. All right, as simple as that. So obviously, in number 10, you would add 3. I'm sorry, wrong. What would you do in number 10? Subtract 3. Fine, I'll do it. Whatever. I'm not doing all the ones on the bottom. And then you change it to an exponent. By the way, what's 10 minus 3? 7. And then when I change this to a logarithm, I said that wrong again. Change the exponent to a logarithm. It's log base 2 of 7 equals x minus 1. Can you take 2 to a power and get 7 in your head? No. If it was 8, yes, but it's not. So no calculator, this would be the answer. Add 1, and it's add 1 separate from the log. That's the answer in calculator ready form. If I went to my calculator, I would type that exactly as it looks. Or I would type this. Remember this. I have a quizzes, I think, for Thursday or Friday after we solve a couple days. That this is another form of this answer, just using what's called the change of base formula. And those logs could also be LNs, both top and bottom. All right. So seeing some questions on the AP website, they leave that in calculator ready form for multiple choice. So you have to be aware of that. All right. And then this one, 2 to the 0. What is 2 to the 0? What is 2 to the 0? What is 2 to the 0? 1. And then how do I get rid of a square root? What do I do to both sides? You square. I don't know why that turned into 1. It's a brain mishap. When you square, when you square both sides, is it plus minus? Do you put plus minus in front of it? Yes or no? When you put plus minus, when you square root both sides to solve. So some rules to remember. That is not a rule. I just wanted to make sure no one did something crazy. Add 8 and you get x equals 9. Right? And then that does work. 9 minus 8 is 1. Square root of 1 is 1. Log base 2 of 1 is 0 because 2 to the 0 equals 1. So some things to remember there. Do we really need to do all of these? We got to log, subtract 1, change the log to an exponent. I'm going to do 14, and then we'll move on. What do you think I should do with that 2? Divide would be smarter, right? I don't know if I'm supposed to say that. You could make this an exponent, but then that makes it a little bit more complicated. What's a lot easier is just dividing by that 2, because 4 divided by 2 can be evaluated. And then this will be the one time that I write it. ln is log base c. And I do have parentheses, so I'm not allowed to subtract 5. That x plus 5 is all together. I screwed up my first hour on the first part of this section. And then if this is no calculator, change a logarithm to an exponent. So base, exponent, answer, and then subtract 5. And then this is the answer in calculator ready format. And then just to know that it exists, sometimes I maybe overestimate what students know and don't know. This is simply what you would type, which I actually still have up here from the other hour. Nope, that's a lie. And I did that wrong. Okay, so let's do that again. I wasn't paying attention. Squared, get out of the exponent, then subtract 5. So good mistake on line there. Okay, so you can get a decimal out of that when you go to the calculator. All right, and then just a couple more here. And this is why, hey, do you remember this? I'm going to go to previous notes and I'm almost done. Do you remember this? These notes? Do you remember this? Do you remember the horse skunk equation? Anyone? Anyone? Right. And I told you I could have Lexi come in, my 8th grader, and actually tell me what the answer is to the next one, because it is pretty easy. When I have 4 to the x equals 4 to the 11, what would Lexi tell me x would have to equal just by matching? What would x have to equal? 11. She knows that, well, I'd have to get rid of this and put an 11 in its place, and then these would look exactly the same. Matching. Yes, you're right, Lexi. That's why x equals 11. So really the mathematical structure is, if I have equal bases, the only way this could be true is if these were equal then. And that's just a rule. That's the horse skunk thing. Really, really true. That's why I gave you that before break. So when I see this, if 5 to this power equals 5 to that, the only way that could be true is if this equals that. The powers. As long as the bases are equal. That's why I said in the beginning, I really don't like changing number 1 to a logarithm. I like 3 to the x equals 81's 3 to some power. Oh, it's 3 to the 4th. So x must equal 4. It's a simple matching. And also, this would be better to be done like this. Well, wait a minute. 16 is 4 to some power, 4 squared, but it's flipped. So that's the negative exponent rule. Oh, well then x must equal -2. All right. So that's kind of how you want to approach these questions, and you darn tootin' will have questions like this on the no calculator portion of our next test. And I do believe it has to be a test because it's the closure. We'll see what the other communists say. They might say it's a short section, so it might be out of 50. I don't know. But it is the closure of logarithms, our next test. Then we're moving on to Moving on to sorry, what's it called? Trigonometry. All right, I'm only doing 18, and then we only have 2 more after this. Can I divide by 2? Well, the answer to that is, of course, yes. Should I divide by 2? Yes or no? No. Creates a big fat mess. If I divided by 2 on this one, this can't be divided by 2. I have an algebraic ugliness there. So no dividing by 2. So what should I do with this 2? I should make it a what? Make it an exponent. So this becomes log of 3 squared, and then this equals log of 1 minus 2x. And then I'm going to jump back to our notes before break when I added that little thing. That's the wrong one. Solving. Where's that? There we go. When I added this, that's the horse skunk idea. If I have log of x equals log of y, well, then x has to equal y just by matching. If log equals log, then the arguments must be equal. All right. And I actually am going to close the notes with that, that little restatement there. So you're not doing any math by dropping the logs. You're doing like a matching kind of thing. Log equals log. Well, then the arguments have to equal. Right. And then that will give me the solution I need. Subtract 1. Wait a minute. Didn't I tell you can't have a negative answer? Not necessarily. What happens when I plug in -4? Does this work? What's -2 times -4? 8. What's 8 plus 1? 9. So that doesn't give me a negative on the inside of the logarithm. So domain issues are going to be big tomorrow. That's why tomorrow is another day of solving, but more issues with logarithms. Big issue when you get answers that don't work. So on this page, this is exactly that strategy we just did. All right. It's exactly what happened on the previous page. B to the m equals b to the n only if m equals n. Log base b of m equals log base b of n only if m equals n. All right. So basically you drop those logs. But this is why I did our work in the quiz is. Now I have 3 logs. All right. Well, you got to do something about this. What's sum? What does sum turn into, everyone? 3, 2, 1, go. Multiplication. Only a couple answered. You can barely hear my students anyway. The second hour, they were my least talkative. But they blew away first hour in the quizzes by 7%. Well done. We'll see how third hour does. All right. And then I shouldn't have to explain it. All right. So it's log base 7 of the product of both 2 and x. And lo and behold, I have log base 7 of this equals log base 7 of that. The only way that's true is if this equals that. And then x equals 10. One thing you want to do with logarithms is at least check that when I plug it in, I don't get 0 or don't get a negative. And I thought I did cover that with you. I know last hour I typed it in the calculator. I might be having a flashback. It might have been this hour, but here's log of 0. Doesn't work because clear. 10 to what power equals 0? 10 to the 0 is 1. There's no answer for this question. Then also, what's the answer to this one? Log base 10 of -10. Do you get -1 for that? What's 10 to the negative first? What's 10 to the negative first? 1/10. This is why this doesn't work either. Enter. 2 errors. We trust the calculator maybe more than crusty old ugly Mr. Samuelus. But that's why I kind of typed that in there. Then last but not least, you want to get nuts? Let's get nuts. What's minus mean? What's minus mean? Division. All right, so last question, but just wait. I thought I heard the door. Okay, and it's not ln over ln. It's ln of. All right, a fraction. And then I have ln of this equals ln of that. The only way that's true is if this equals that. By the way, x over, anyone? What's the denominator of x? 1. Why did I do that? What are we going to do to solve for this? Crisscross what? Multiply. What's x times x? X squared. I like doing this way because the x squared I like over here. and then the x plus 6 over here. How do I solve this one? Hey, by the way, good foilers, anyone? How are we going to solve this one? Factoring. What if you can't factor? Anyone? The opposite of, no, b plus or minus the square root of b squared minus 4ac all over 2a. If you do that on this one, I'll throw up on your paper. What multiply? He's so mean. What multiplies to negative 6 and adds to be negative 1? What two numbers? Negative 3, positive. Now you better watch. You better listen. I know I've talked a lot. You know, kids these days, can they keep their attentions? This is the big thing. This is the big thing. So x equals 3, x equals negative 2. You need to check your answers with logarithms. You're not really totally checking, no. You're checking, do I get something that evaluates in the original? Does this create a positive on the inside when I plug in 3? Yes or no? Yes, we're good. Does this create a positive and not 0 when I plug in negative 2 there? It's already over. This is a naughty answer. It's called extraneous. That's a fancy word for I did valid math, but I got an answer that doesn't work with the original. Okay, and that's what the word extraneous really means in my world. All right. So you have to check your answers with logarithms, and we're gonna hit this the next 2 days quite a bit. Actually, next 3 about logarithms and that little problem. All right, and then this was a reiteration. Another author of the notes, Cooper Westbury, they had a great idea in that the next position, but really this is what it's saying. You're going to run into a few things. You're going to run into equal bases for exponents. Just set the exponents equal, or you're going to run into log equals log quite a bit. Drop the logs and solve. If you don't have that, if you get it in log form, change it to an exponent. You'll be able to solve. You have it in exponent form, change it to a log. If you have several logs on one side, use a rule. All right, it's usually the sum or subtraction rule. All right, and then get it into one logarithm on that side, and then you could have either or of your situations there. All right, and then just some things to consider as you're packing up. Worry about logs. You can get extraneous solutions when you're dealing with log equations. If you have time, though, you can check your answers, but sometimes we don't have that time. All right, good to see you back. Hey, look at Mr. Samuelis going all the way to 2 minutes left.